that the last time, so.
So what are we doing?
Alright, so what we're doing is the water heater stopped working on propane mode, and so it works on electric fine. I can see the valve opening and closing. I can smell propane. I can even light it manually, but there's no ignition. So I posted a question on the Facebook page, and someone suggested I pull the ECO spring off and reset it. And this is the ECO spring, or ECO switch in here, and it just holds it against the water heater base. Anyway, when I went to pull the retaining off, I broke this plastic retainer, and I turned what should be a simple job into a really big one. So what I'm going to try to do now is take my vernier caliper and design a new one on Tinkercad and 3D print a replacement and try that. Alright, so what I'm going to do is take a few dimensions off my broken one and start by turning it on and just get some basic dimensions like the outer circumference, and then I'm just going to come up here, see if I can get this to point up. I really need to make more room for myself. Got a lot of different stuff going on in here, a lot of junk. Alright, so we're going to start by a tube. We'll start with that. And alright. And then let's measure the thickness of the plastic here. So we measure its thickness. It's 0.03 inches. Turn this to millimeters. Make it easier. 0.83 millimeters. I think I could probably get away with 0.9, make it a little bit thicker so it's maybe a little bit denser. Should look similar to cut out right there. Now I'm actually gonna undo that and take that and duplicate a second one, pull that out, group it again, get the cutout back, because there's actually another feature up here at the top. You can see up here at the top. So I'm taking my vernier caliper and I'm just going to measure that. Does it look the same? That up there. Okay. I think that's ready for a trial print. Open it in here. Which will reopen Microbot slicing software. And there's our object. So I haven't done this in a while. I haven't run my 3D printer, but if I remember, you just have to make sure it's all the way down, and then let's see. Okay, from here. Stick our thumb drive in here, and we're going to hit print, see what it loads. And there's our image, and then We're going to clear off our limits, and then we're going to hit print. Alright, here's the broken one, and there is the 3D printed one, the replacement. So, and a couple little scraggling pieces of plastic on there, but looks like it might work. Just right over in its place. Let's go try it, put it on. It went in like that the last time, so I'm just going to try to put it back in. Trying to get it to go in now. Alright, so I managed to break my new 3D printed one. So the cool thing about 3D printers is you can print another one. So round 2. Alright, number 2. I'll try and be a little gentler trying to put it in. If I break it again, I could go in and reinforce some of these corners here and make it a little thicker. Just try to make the design a little tougher. Pretty cool when you have the ability to manufacture new parts right in your rig. 3D printer, pretty handy. Alright, you can see I'm still cracking it a little bit, getting it in there. But this one's in. So this is the 3D printed retainer. I may change this design of this a little bit to make it a little more durable as I'm putting it in. But it is holding the spring in at the moment. So let's give the water heater a try. Alright, I'm going to try the water heater. See what it does here. Trying to get this thing to ignite on propane. Alrighty. Alright, you can hear the gas kicking on, but no ignition. And the spring is in, so it shouldn't be the issue. Something else. There might be something wrong with the controller. Not sure what it is, but it works in electric mode but not in propane mode. So on to the next thing to figure out what could be the trouble here. So yeah, the 3D printer you just watched there, that is a MakerBot 5th generation with the smart extruder. It is a PLA type printer, which means it does not have the heated plate. The PLA type plastic that it prints is a lot less prone to warpage than the ABS is. And I bought it originally. I bought it for my business. I was printing a lot of enclosures for prototype circuit card assemblies and things like that. And since my business is now in the RV with me, it's a piece of equipment that I use periodically, and it makes it very handy whenever I need to build something for the RV. Alright, I'm also trying to get the coax connected up to the RV at the connection point there from the block outside, and get it driving the outdoor kitchen. There's a TV in the hanging on a mount on the outdoor kitchen. I'm trying to get that going. And mainly so that we can watch the football game over the holidays. I have not connected the cable to the cable from the cable box outside. Most of the RV parks have a cable connection, and this one does too. and I've routed. I went and bought a cable so I could connect up the RV, but I mean, we've had the RV for 10 months. We've been RVing for more than 2 years, and this is the first time I've ever connected up a coax cable to any RV. And it's mainly because we're cord cutters. We don't watch live broadcast television, and used to do a lot of that just sitting around on a couch. Not very healthy, especially if you want to get out and do things. It's just best to stay away from that. So we watch things like YouTube and Amazon Prime that have a limited selection. We have DVDs as well, and I like to keep it that way. So I probably won't connect it up to the TV in here, because I just rather leave the cord cut, and it's just easier if it's not around to fight that temptation. So yeah. All right, well, that's all for today, and we'll see you next time.